Welcome to the 6th Learning Mashroom Server lesson. This time we will finally see how microfrontends running on a remote host can be integrated into the portal. Manually integrated to a standalone Mashroom portal and dynamically to a portal on a microfrontend platform on Kubernetes. At the end, we will briefly talk about how to pass the portal security context to backends. This time I start with a prepared workspace that already contains a folder with a Mashroom portal, very similar to the one used in the previous lessons, and an empty microfrontend1 folder where the standalone microservice will go. I've added 2 additional plugins to the Mashroom setup, Mashroom Background Jobs and Mashroom Portal Remote App Registry, and a corresponding plugin configuration that tells the Remote App Registry to get the list of remote URLs from the Remote Microfrontends.json, which is empty at the moment. For the Remote Microfrontend, we are going to use Svelte as framework, just because it seems to be very popular at the moment. Unfortunately, the official way to create a new app always uses SvelteKit nowadays, which is a full-blown application framework and not suitable for microfrontends. So we use the Git instead to create an app. So enter npx digit svelte.js/template microfrontend1 and enable TypeScript by executing setup typescript.js. Now run npm install and start the dev script. The app should now be available at localhost 8080. Now we have to fix a few things in the app setup. If you have a look at main.ts, the app is spawned in the body container, which is not suitable for microfrontends. Instead, we have to create a bootstrap that gets the container and the config passed. And we have to change the startup procedure in index.html as well. All very similar to what we did in lesson 4 with the React app. As name, we pass an app config property or just the user's display name as default. If you are going to build dynamic cockpits, it's very important to properly unmount the app. In case of Svelte, you should call app $destroy. Then we need a mashroom.json file with the plugin configuration, also similar to lesson 4. The only difference here is that we also state a remote configuration with the path where the resources can be found on the remote server. Now, how can Mashroom Portal find this plugin config on a remote server? It simply expects mashroom.json and ideally also package.json is available under / on the remote server URL. One way to get mashroom.json and package.json exposed is to simply copy it into the public folder and the HTTP server will serve it. For example, with the rollup copy plugin. Since we also want to have a simple API on our server, I'm going to use Express instead of serve CLI. So we add Express to the dependencies and also TS node to avoid an extra compile step. Then add a server TS that serves everything in the public folder and also the two JSON files. We also have to adapt the start script. If you run the app now, you will get an error unknown file extension. To fix this, remove type module from package.js and change the rollup config file extension to m.js because it uses ES6 modules. Try again, and the app will now run on port 8888, and package.json and the Mashroom.json are available. The only thing left to do now is to add the URL of the microfrontend to remote microfrontends.ts and start the portal with npm start. Open localhost 8080, log in as admin and check out the admin UI under /mashroom. The microfrontend should appear under Remote Portal Apps. Now you can add the Svelte microfrontend to any page, for example home. As you can see, there are still a few integration problems. First of all, the loading animation doesn't disappear. The reason is that Mashroom expects the app to clear the host container, but Svelte seems not to do that. So we have to do it manually in main.ts. Then the layout is broken because the app uses the main element, which is not a good idea in a microfrontend. It is usually already used in a page template and styled by the host, so we just replace it by a div. Okay, looks much better already. To demonstrate how the built-in HTTP proxy works with remote microfrontends, I'm going to add a simple API route that basically just returns host information. And now fetch the data in the app and display it. Works pretty well in the standalone version. It doesn't work in the portal though, because the path API OS doesn't exist. We could now try to fetch the data from the full server URL, but that also won't work because by default the browser does not allow cross-origin requests. So we need to ask the portal to provide us a proxy to be able to access our API. Open mashroom.json in the microfrontend project and add a proxy config there. We use your local host in the target URI, and Mashroom will automatically replace it by the actual host name and port in case of remote microfrontends. In the app, we introduce a parameter API path and set it from the proxy path object passed by the portal. We also have to set the proxy path in the app setup for the local development in index.html. In the portal, we have to refresh the app registration and then it should work. The refresh would happen automatically after some time. Okay, that's nice. But wouldn't it be cooler to deploy our microfrontend on a Kubernetes platform and the portal instance there would automatically pick it up? Let's do this. You need to install the demo platform from our microfrontend platform Kubernetes repository. I will post a link in the comment section. Just follow the K3D setup guide to install the platform. This will only take a few minutes. After that, you should see the following in Lens: the portal and a bunch of common services in the Mashroom common namespace, and 2 demo microfrontends in the microfrontends 1 namespace. What we want to do now is to deploy our microfrontend in a new namespace with the correct labels, so the portal will pick it up. First of all, we need a Docker file. Nothing particular here. Then we need the Kubernetes resources like namespace, deployment, and service. Please note the labels on the namespace, which are necessary so the portal checks it for microfrontends. Finally, we need a script which builds the image, pushes it into the registry, and applies the Kubernetes resources. Let's run the script and wait until the deployment is ready. Open the Mashroom portal running on the Kubernetes cluster at HTTP localhost 30.082. Login with admin. First, switch to the admin UI under /mashroom and check if the new namespace and the microfrontend has been picked up. Then you can add it to any portal page or test it in the sandbox. A few words regarding the deployment on Kubernetes. The portal there runs in production mode with caching enabled. That means as long as you don't increase the module version in package.json, you probably won't see any effect in the UI when you redeploy. You need either to bump the version with every build or add some timestamp suffix to the version during the build. At the end, a very important aspect. On a remote server, you don't run in the security context of the portal, but typically you need to know who is calling you for authorization. For example, if the current user is even permitted to see the requested data. Mashroom provides multiple possible mechanisms that will help you in that regard. If you have role permissions defined in the app, you can send the current permissions in an HTTP header. All you have to do is enable Send Permissions header in the proxy config and check the X user permissions header in the API. You can also install the Mashroom HTTP proxy add user headers plugin, which will add user data to every HTTP request. For example, the username will be available in the X username header. Those two approaches only make sense for backend for frontends, which run in a protected environment and are never exposed to the outside world. For example, within the same Kubernetes cluster where the portal runs. The safest approach would be to forward the portal's OAuth access token as bearer. The token is signed and can be validated against the public certificate of the trusted IDP. You need to use Mashroom security provider OpenID Connect for authentication and additionally have to install the Mashroom HTTP proxy add ID token plugin. As usual, the code for this lesson will be available in a public Git repository. I will add the link to the comments section. And I will also add the link to the demo Kubernetes platform.